Back, Chapter 6, Section 6.3, Additional Properties of the Binomial Distribution. Focus points. Here we make histograms for binomial distributions. We compute mu and sigma for a binomial distribution. Graphing a binomial distribution. Any probability distribution may be represented in a graphic form. How should we graph the binomial distribution? Remember, the binomial distribution tells us probability of R successes out of n trials. Therefore, we'll place values of R along the horizontal axis and values of probability of R on the vertical axis. The binomial distribution is a discrete probability distribution because R can assume only whole number values such as 0, 1, 2, 3. So number of successes, right? Therefore, a histogram is an appropriate graph of a binomial distribution. How do you graph a binomial distribution? Place R on the horizontal axis. Place probability of R on the vertical axis. Construct a bar over each R, value extending from R minus 0.5 to R plus 0.5. This is to make sure that the width of each rectangle is precisely 1. The height of each bar is probability of R. A waiter so here is an example. A waiter at the Green Spot restaurants has learned from long experience that the probability that a lone diner will leave a tip is only 0.7. Okay, 0.7 is the probability that a lone diner will leave a tip. So this is probability of success. During one lunch hour, the waiter serves 6 people who are dining by themselves. 6, so number of trials, n is 6. Make a graph of the binomial probability distribution that shows the probabilities that 0 to 6 lone diners leave tips. N is 6. Probability of success is 0.7. Therefore, probability of failure is 0.3. Remember, probability of failure is 1 minus probability of success. So it's 0.3. So you have this table. How did we get these numbers? We can use our table, you see. So let me figure out the table. We have 6 trials. Probability of success is 0.7. So that's that. So let me hold it there. Hold this there. So we agree on we check whether our numbers agree. Right? So 6 trials. Your 0.01, 0.010, so on. 118. So correct. So that's the column we are looking for. N equals 6, P equals 0.5. Using this, now we are going to construct a histogram. R goes on the horizontal x-axis, probability of R on the vertical axis. So you see you had to squiggle your line because you are starting 0 success. 0 success to 6 success. So the central number is R, and then the width is go 0.5 to the left, 0.5 to the right. Do the same with 5, 0.5 to the left, 0.5 to the right, and so on. So each width is 1 and each height is the probability for those many successes. So area of this rectangle will be 1 times the height, that is. So area itself is probability of 4. Area of this rectangle is probability for 3, and so on. So this is your histogram, all right, which is graph of the binomial distribution in our case. Now, the probability of a particular value of R is not only given by the height of the bar, but also by the area. Each bar is only 1 unit wide, so its area is height times width, which is the height. Area of each bar represents probability of the R value under it. The sum of the areas must be 1. If you add up these numbers right now, these areas, which are nothing but these numbers, if you add them up, you should get 1. But if you add them up, you actually get 1 point a little more, and that is because of the approximation that is used in our table. Our table uses approximate values, so this is a rounding error. All right. Next, mean and standard deviation. Okay. Now you want to understand mean and standard deviation of a binomial distribution. Two other features that help describe graph of any distribution are about the balance point of the distribution and the spread. Balance point is the mean mu, and measure of spread is the standard deviation sigma. The mean mu is the expected value of the number of successes. For the binomial distribution, we can use two special formulas to compute the mean and standard deviation. So here are the formulas. How to compute mu and sigma for a binomial distribution. So we will continue on this slide in our next video.